Hello, this is test 1 review for Math 1620. Our first test is going to be in Webassign. You will have to, so you'll log into WebEx and wait for me, and then I'll give you, you also want to be logged in the Webassign. You're going to need the lockdown browser thing they have for this. It should automatically download, but you may want to check it out before you go in there and try to take the test. So the test 1 is up. It's password protected though. So on the day of the test, you have to go into WebEx, and I'm watching you through WebEx. I have to watch you while you take the test. We don't give any non-proctored tests, or I don't. So you should have a webcam that works. I should be able to see you. You'll log in the WebEx, with your webcam. You'll also log into Webassign. I'll want to see your work area, so ideally you point your camera down towards your work area, and that way I can see that you're not using a cell phone. You should have scratch paper because you need to write out your answers on the paper, and when the test is over you got to turn that in. Okay, so I know you didn't cheat, so I know that you did work. What else? So you'll log in the WebEx. I'll want to see your scratch paper to make sure there's not written on it, and then I need to see your workspace, and then I'll give you the password for Webassign, and then you can go ahead and begin. I think it's set so you have 2 chances on each question, so there shouldn't be any of this like you accidentally typed it in wrong or anything like that. If it turns out you did type something in wrong, just let me know after you take the test, and then I can go in there and check it. And if it is written wrong, I'll give you credit. Okay. So I know there's every once in a while there's something that's kind of annoying, and it's just you have to type it in correctly. Okay. So hopefully that's the idea. You got the idea. You need a webcam that works. Okay. If you do not have a webcam, if it does not work, I will not let you take the test. Okay. All right. So anyways. First off, I'll give you kind of the question pool. This is where I'm getting my questions, and it'll help significantly sort of narrow down the possible types of questions. So 5, 7, 5 to 23 odd, and then 33 to 41 odd. And of course, if you have the ebook, you can just look in the ebook and for these, but also in Webassign, the actual problem numbers are on the question. So if you go in the Webassign, sorry, I got to log in and everything. Like in 5.8, you see it says LAR Calc ET7 5.8.003. That 003 is the number of the question in Webassign. So, for example, in 5.8, I'm going to be looking at questions similar to 3 to 15 odd. So 5.8, we have questions 3 to 15 odd. So if you go in the Webassign and look at those kinds of questions, so the first 6 questions, I'll find one that's similar to those. Okay, so hopefully that helps a lot. Let's see what else. 5.9, questions like 25 to 33 odd, and then 45 to 53 odd. There's no notes allowed on the test, so I'm not giving you any formulas on a note card or anything like that. You can't use the high-powered calculators, so you have to use a TI-84 plus or below. If you have something above it, I won't let you use it. You really only need a scientific calculator, but you can use one of the TI-84, 83, 82, 81. Those are all fine. No cell phones. Cell phones are bad news. 6.2, 23 to 25 odd, and then 29 to 35 odd. 6.3, 3 to 25 odd. 6.4 over here. 11 to 13 odd, and then 6.5 is the last section on this test, 7 to 13 odd, and then 17 to 23 odd. Other little technicalities, if you turn in work that's obviously written in somebody else's handwriting, like I have your homework, your video homework submissions, and if your handwriting is not the same, if it's clear, I'm not going to hire like one of those guys that analyzes handwriting. But if it's clear that these handwriting styles do not match, you have trouble. Okay, I'll make you retake the test. What else? If in your work, so again, you're turning in your work after you take the test, you're going to have to scan your documents somehow, either using a camera or if you have a scanner, use a scanner. You have to scan them, upload them, convert the PDF, and send to my email. If I look at those and it's obvious you used like Symbol Lab, because I could do the problems of Symbol Lab and see what answers they give me. If it's obvious you just copied all your answers from Symbol Lab or Mathway or something like that, I'll give you a 0 on the assignment, and you could come into my office hours and haggle with me or complain about it. What else? If it's clear that you're using methods that are like maybe a graduate student would use, then I'm not going to allow that either, or I'll give you a 0 and you can defend it in my office hours, okay? So it's because of the pandemic. I blame the pandemic, okay? I'm not trying to be mean or anything, but we have to clamp down on the academic integrity pretty hard, or the credit you get from our institution won't be worth anything. Okay. So, anyways, hopefully that gives you this is a pretty good idea. My tests are pretty straightforward. So I'm going to pick some questions out of these questions that I have listed, and if these are the types of questions you're going to see. I'm not going to throw anything clever at you. I'm not all that creative anymore. As the older I get, the less creative I am. So anyways, here we go. So for 5.7, it's, you have to have memorized our natural log formula, which is this. Okay, so something like number 7, 1 all over 2x plus 5 dx. This requires a u sub, and I mean, there's going to be a factor of 1/2. If you could do it without a u sub, that's great. But if not, you're going to have to go through the u sub. 2 dx, and then the dx is du over 2. You definitely want to show work. The less work you show, the more I'm going to be like, did this person just, use a calculator? So show your work. Bring out the 1/2 over u du, and then we have 1/2 ln absolute value of u plus c, and then finally back sub 1/2 ln absolute value of 2x plus 5 plus c. Okay. All right. So there's substitutions. There were long division problems. So here's one that's a long division. You have to know how to do long division. Over x squared plus 2 dx. When I do this kind of long division, I like to use placeholders. You may or may not like to use placeholders. So what's a placeholder? It's just when you don't have that particular degree term, like it should go x squared plus something x to the first power plus 2. If you don't have that x to the first, like we don't have here, I just put a 0 in its place. When I was in your shoes, I never did that, and I always got it to work out, but it's just a nice habit to have. So this would be 0x cubes plus 0x squares. And all it does is line things up. So it makes the division a little easier. Okay. So what times x squared gives me x to the 4th? Well, x squared. So I'll have x to the 4th plus 0x cubes plus 2x squares. Then I subtract. Okay. So negative 2x squared to bring down. So what times x squared gives me negative 2x squared? That would be negative 2. So I get negative 2x squares. And of course, bring down the stuff above as well. I forgot to do that. Plus 0, x is minus 4. And then we subtract again. Don't forget to distribute the negative there. So 0x squares, and then 1x, and then 0 for the constants. And then to rewrite the integrand, it's x squared minus 2 plus x all over x squared plus 2. Okay, so let me rewrite this. This will be the integral of x squared minus 2 plus the remainder all over the thing you were dividing by. So the first two parts of the integral are just power rules. So you x cubed over 3 minus 2x. The third one requires a u sub. So I'll let u be the denominator there, the x squared plus 2. And then du will be 2x dx. And that'll give you dx of du over 2x. So we amend here. So it'll be the integral of x over u times du all over 2x. And then you're going x cubed over 3 minus 2x. And you can bring out the 1/2, and you end up with a natural log integral on the inside here. So this will be x cubed over 3 minus 2x plus 1/2 ln absolute value of u, which is x squared plus 2 in this case, plus c. Then we'll have, yeah, that's it. Yeah, that's it. Okay. Okay. Let's move on to a trig version. So number 33, we have the integral of cotan of theta over 3 d theta. Okay. So in order to pull this one off, you probably don't have it memorized, right? But you can always rewrite cotan and tan as quotients of cosine and sine. So cotan is the same as cosine all over sine. So you should have the basic trig identities memorized. D theta. And then you could do a u sub and it will turn into a natural log integral. So right, u is sine of theta over 3. And then du will be cosine of theta over 3 times 1/3 by the chain rule. It's just the derivative of theta over 3. And then d theta, and then solve for your d theta. So you'd end up with 3 all over cosine of theta over 3 du. And then you just do your substitutions. So this thing will become cosine of theta over 3 all over u times d theta, which is now 3 all over cosine of theta over 3 du. Magically, the cosines of theta over 3 disappear, and you are left with, then you can factor out u3, and you get 1 over u du. That's just a natural log. So 3 ln absolute value of u plus c. And then finally back sub, and you have your answer. So 3 ln absolute value of sine of theta over 3, and then plus c. Okay. Okay. 5.8 is the section on the inverse trig function. So you should have these two formula memorized. What were they? 1 all over the square root of a squared minus u squared du is the arc sine. Arc sine of u all over a plus c. And then the other guy, 1 all over a squared plus u squared du is 1 over a arc tan of u over a plus c. So you need to have those two guys memorized. And let's take a look at some examples. So the first one, t all over the square root of 1 minus t to the 4th dt. So I want to get it into one of these forms, right? So it's probably an arc sine. So I'm going to let my u be t squared. Okay. Because t to the 4th is just t squared squared, right? That's the idea. 2t dt, getting the differential, and then dt is du over 2t. That'll cancel out the t in the numerator. It'll be a 1/2 constant floating about. So we have t all over the square root 1 minus u squared times du over 2t. Okay. So again, the t's this time magically disappear, and you can factor out 1/2. Put that in white. Integral of du all over the square root of 1 minus u squared. So now we have our form that we have memorized with an a value of 1. So it'll be arc sine. Whoops, I lost my 1/2. So don't do that. Don't be like me. Okay. So I have 1/2 arc sine of u all over a. A is just 1, so I can just put u and then plus c. And then, of course, back sub 1/2 arc sine of t squared plus c. Okay. So know those. Know your natural logs as well. Or sorry, your arc tangents as well. Let's do an arc tan. Something like this: x minus 3 all over x squared plus 1. So it's not in the form yet. You're going to have to butterfly this one. So we end up with an integral x over x squared plus 1 dx minus, you can factor 3 out, integral 1 all over x squared plus 1 dx. That second integral is just a tan inverse. The first integral, you got to do a u sub. Okay, so our first integral x all over u times dx, which is now du over 2x minus 3, and that's a arc tan with a value of 1. So we have arc tan of u in this case is just x all over 1, and then plus your integration constant. Let's go ahead and factor out the 1/2 from that first integral. The x's magically disappear. So we have the integral of du over u minus 3 arc tan of x plus c. And we end up with a 1/2 ln absolute value u minus 3 arc tan of x plus c, and then back sub, and you're done. Okay, so you get 1/2 ln absolute value x squared plus 1. You don't really need the absolute value there. 3 arc tan of x plus c. The insides of the natural log are always positive. X squared is always greater than or equal to 0, and then if you add 1, x squared plus 1 will always be greater than or equal to 1. So you don't need the absolute value. You can kind of drop that if you want. Okay, anyways, 5.9 was on the hyperbolics. So I expect you to have memorized the basic derivatives for sinh, cosh, tanh, as well as cosech, sech, and coth. Okay. So if you know, and you're supposed to have the trig derivatives memorized, so if you know those, you should know these. Just the signs are different, right? And then if you know those, you know the integrals, so you should know all the basic integrals, like the integral of sinh is cosh. And then you should know the other sort of side, stuff like the integral of hyperbolic secant x, tan x. Hyperbolic tan x dx is negative hyperbolic secant x plus c. So you should be able to do any kind of variation of those. So let's do one, right? So 27, written in the book as y equals hyperbolic secant of, well, I'll show you how it's written first off, of 5x squared. So students see this and they sometimes think it means, which it doesn't, So let me, warning, it does not equal hyperbolic secant of 5x squared. Okay. Hyperbolic secant of 5x squared, if it was like that, they would either write it like that, or they would write the little squared part inside the secant. Okay. So what they really mean is that 5x squared part is in parentheses. So what they really mean is y equals hyperbolic secant of 5x squared. Okay. And there's a whole kind of, I think it comes up more if you're in computer programming, and you have to make sure everything's written well. So it's just like when you're studying English, and everybody's seen maybe on the web, there's 2 answers to this type of question, 5 divided by 1 times 3 minus 2. That please excuse my dear Aunt Sally, it's just a way to, cut down on the nonsense. It tells you how to read expressions like this, So especially in computer science, it becomes an issue because you have to know how to interpret what the user is typing in. So it's an issue there. It's an issue for us too, you as a student and me as a teacher and you as a homework person doer. You have to know how to write things. It used to be a lot easier because you would learn by looking up the answers in the back of the book, but now it's not like that. So anyways, long story short, there it is. Okay. So to get the derivative by prime, it's the derivative of hyperbolic secant is negative hyperbolic secant hyperbolic tan. And then you have to tack on the derivative of 5x squared because of the chain rule. It'll be 10x. Cleaning it up, you want to put this up front so people don't think it's accidentally part of the hyperbolic secant hyperbolic tan or something like that. Just makes it easier to read. So you don't want any misinterpretations, especially in engineering. You can imagine you're building a bridge, your projects are millions and millions of dollars. You make little mistakes or you don't communicate it properly, people lose millions and millions of dollars, which is equivalent to losing lives in some people's opinions. Right? You can imagine how much food that would be. Anyways, let's look at 49, an integral. So you have to know how to do integrals as well. Cosh squared of x minus 1, sinh of x minus 1 dx. This guy is going to require our u sub. So if you don't see it, do a u sub for cosh, and then get your differential is sinh x minus 1 dx, and then dx is du all over sinh of x minus 1. Okay, so this will be the integral of u squared times sinh of x minus 1 times dx, which is now du all over sinh of x minus 1. So those sinh will magically go away, right? And you're just left with a nice power rule on the u squared. So that will end up being u cubed over 3 plus c. And of course you got to back sub it. So we get cosh of x minus 1 cubed over 3 plus c. Be perfectly acceptable. Okay, so 6.1 then is the beginning of differential equations. We began with a kind of just checking our solutions, so there'll be a problem like that. So they give you a differential equation, this guy, and then a potential solution. You got to figure out if it works or not. So we're going to need the fourth derivative here. So by the chain rule, the derivative e to the negative 2x is negative 2 e to the negative 2x, right? So it's just e to the negative 2x times the derivative of negative 2x, which is negative 2. And then y double prime is negative 2 times negative 2 is positive 4, because I'm just tacking on another negative 2 each time. It's negative 8. And then the fourth derivative is positive 16. Okay, so I use that information in order to show that that differential equation is true. If it isn't, then it isn't. So anyways, starting on the left-hand side, so this would be the official way I would do it. Y to the fourth minus 16y, in this case, equals 16e to the negative 2x minus 16 times y, which is e to the negative 2x. And of course, that equals 0, which is the right-hand side, and you're done. So it is a solution. Hence, it is a solution. Yay! The world rejoices. Okay. So we had that stuff. Also, we kind of just introduced you to the idea that, hey, we all know how to do differential equations. All you have to do is integrate. Okay, so here's one I like to bother students with all the time in Calc 1. So, oldie but a goodie. In order to figure this out, all you have to do is integrate. So y will equal the integral of x times the square root of x minus 6 dx. Okay, so u equals x minus 6, du ends up being dx. So real work to do there, but when you do the integral, there's something happens, right? So you get x times the square root of u times du, and that x doesn't go away. So what do? You have to go back to the original equation here and rewrite x. So x will be u plus 6. Okay, so I have the integral of u plus 6 times the square root of u, which is the same as u to the 1/2 du. And so we can distribute the u to the 1/2, and you have u now to the 3/2 plus 6u to the 1/2 du. And then you just do power rules, and you should be home free. So I have u to the 5/2 times 2/5 plus 6u to now the 3/2 times 2/3 plus c, and then you have the back sub. So our solution y is equal to 2/5 times x minus 6 to the 5/2 plus, wasn't 6 2 times, 4 times x minus 6 to the 3/2 plus your integration constant. Okay. Okay, so, awesome. You already know how to do differential equations, even if you didn't know it. 6.2, we look at the first model of differential equations, which was the logistic growth model, the exponential growth model, y equals ce to the kt. So it has some problems associated with that issue. So the chart problems, like number 33, we have carbon 14, and they give you the half-life 5715 years, and I think they also give you in this problem the initial amount, and they want to know how much is left after 1,000 years, and then how much is left after 10,000 years. Okay, so I use the y equals ce to the kt. You should probably have that memorized, that formula. And what do? I need to substitute in information. So they give you the initial value, which is c. So that's 5e to the kt. And then I have to figure out what k is using the half-life. Okay, so 1/2, if you wish, 1/2 of 5 is equal to 5e to the 5715 for years, for time, times k. And then when you divide by 5, you end up with 1/2 equals, you could skip you could just write 1/2 e to the 5715k. I want you to show work, though. I don't want you just to have formulas memorized. I'm more about learning programs, So anyways, take ln on both sides. You end up with 5715k equals ln of 1/2, and then solve for k. All over 5715. And then you have kind of your official formula that you could use to answer their questions. E to the ln of 1/2 all over 5715, and then times t. Okay, so you go to your calculator, plug in 1,000, For t, I got 4.43 grams to 2 decimals. And then plug in 10,000, and I got 1.49 grams. Okay, so be able to do variations of those problems for exponential decay. 6.3, we get separation of variables. So you get all the y stuff on one side, all the constants and the x stuff on the other. Let's look at some variations on that. 2 plus x, y prime equals 3y. Okay, so we can re-envision y prime as dy over dx. Those are equivalent. Get the y stuff on one side, the x stuff on the other. I leave my constants on the right, so I end up with dy all over y equals 3 all over 2 plus x dx. And then you want to integrate both sides. So you end up with ln absolute value of y equals, you can factor out 3. If you need to do a u sub, you can. You don't really need it though, because if you let u equal 2 plus x, du will just be dx. Okay, so you don't really need the u sub. And you end up with ln absolute value of y equals 3 ln absolute value of 2 plus x plus c. Okay. And then you want an explicit solution. So you're going to exponentiate both sides. So you get e to the ln absolute value of y equals e to the 3 ln absolute value of 2 plus x plus c. On the left, there you're going to rewrite that as absolute value of y. On the right, you're going to kind of split it up into two exponential parts, e to the c times e to the 3 ln absolute value of 2 plus x. Use power rule to bring this 3 inside the, you have to do this before you can simplify. So you have e to the c times e to the ln absolute value of 2 plus x cubed. And then you can simplify this, right? Because the e and the ln are kind of touching, so they will go away. Now e to the c times absolute value of 2 plus x cubed. Then you could drop the absolute values on both sides, and you end up with plus minus e to the c times 2 plus x cubed, and then you could replace this thing with a general constant. So we see y equals c times 2 plus x cubed. Okay. Okay, it's probably kind of a big leap of faith for people to accept that the absolute value. So one thing you can do to kind of see, why can I drop those absolute values and just, go from here to here. Just consider y equals, and let's let c equal 1. Okay, so consider y equals 2 plus x cubed. And y equals negative 2 plus x cubed, and then also the absolute value of y equals the absolute value of 2 plus x cubed. So I just let c equal 1, and I want to prove to you that these two things are basically the same as this. In other words, you could drop all the absolute values and just replace it with a plus or minus. Okay. So you can see it in Desmos. So let me clear out that first guy. The positive 2 plus x cubed is this first blue curve, and then the negative one is this green curve going down, and then we can get rid of the, put this guy in, this first guy, the red guy, and get rid of these, and you'll see it's the same thing. Okay, if nothing else, hopefully that kind of convinces you that, oh yeah, those are the same. You can pull that trick. Okay, so let's move on to one of these initial condition type problems. So number 19, y times x plus 1 plus y prime is 0, and y of negative 2 is 1. So this time it's not separated. So let's move, let's rewrite y prime as dy over dx. Move the y times x plus 1 to the other side. So I end up with negative y times x plus 1. And separate. So dy over y, and on the other side, negative x plus 1 dx. Integrate on both sides. So I'll have ln absolute value of y equals negative x squared over 2 minus x. Don't forget there's that negative in front, so I have to distribute in my antiderivative. You want to exponentiate both sides. So you have absolute value of y equals e to the c times e to the negative x squared over 2 minus x. Drop the absolute values, plus or minus, then replace the plus or minus e to the c with a big C. Okay, you could just skip like that if you want. And then use your initial value to get c. So y of negative 2, they said is 1, I believe. Yeah. Okay, so this is x here, this is y, so y is 1 equals c e to the negative 2 squared is 4 all over 2 minus negative 2. So we got a bit of arithmetic. E to the negative 2 plus 2 gives me just 0. So 1 equals c. E to the 0 is 1, so c is 1. So my particular solution, 1 times e to the negative x squared over 2 minus x. Okay. 6.4 is on the logistic equation. So you have to be able to kind of pick out the bits and pieces. Here's the logistic equation. It's L, the limiting capacity, all over 1 plus B e to the negative kt. And then the logistic differential equation, you kind of have to know too, I believe, is dy over dt equals k times y times 1 minus. So, I mean, the first part is just the exponential growth model. The rate of change of the population is proportional to the population. But with the logistic differential equation, they tack on this extra 1 minus y over L. Okay, so on our question, we'll be kind of putting all that together to figure out the answers. So P of t is 2100 all over 1 plus 29 e to the negative 0.75 t. And a lot of these questions are just identify K, identify L. So you're only going to be given this, the logistic equation, okay? And you have to identify the bits and pieces. So part A, they want to know what K is. K is just the 0.75 without the negative, okay? That negative is in the formula. The K is without the negative. The limiting capacity, L, is in the numerator. That's 2100. They want to know what's the initial population. So that's just going to be P at time 0. So you put 0 in for T, and you get 1 plus 29. E to the 0 is just 1. So 1 plus 29 times 1 is 1 plus 29. That will be 2100 over 30. Which is 21 over 3, which is 7. Okay. Part D, they want you to find when is the population at 50% of the limiting capacity. So 50% of the limiting capacity means basically 50%, so 0.5 of 2100. And when is our population equal to that? And the population, you can figure out what it is at any given time t by using the logistic equation, 2100 over 1 plus 29 e to the negative 0.75 t. So solve this for t. All right. Okay, so what do we have? Divide, cross multiply or whatever, you're going to end up with 1 plus 29 e to the negative 0.75 t. That'll equal 2 eventually. So 29 e to the negative 0.1. Divide. Take natural logs. And divide. calculator says this is approximately 4 point, and it's supposed to be in years. Okay. Part E, they want you to write out the logistic differential equation. So you should have that formula memorized. This thing right here, you got to have that memorized. So you're just filling in the K and the L. You have to be a little careful, I think, though, and the computer's going to be a jerk about it. Use a capital P if the original equation is given as P of T. You got to use a capital P. Okay, so it'll be K, which is 0.75 times, instead of YP, times 1 minus P all over the limiting population, which is 2100. So that'll be your logistic differential equation. Okay. Okay. 6.5 then is on the integrating factor. So be able to do the general and the particular solution types. Let's look at a general type. And this one is a mess, the way they give it to you in the book. So I just wanted to show you this in particular because they're more messy once you get the differential equations. They're not going to give them to you on a silver platter. Anyways, the first thing you have to do is get it into the, your differential, first order linear differential form, which is this thing. So I'm going to get the d, just push everything to the other side. So you end up with a dy, or add everything to the other side, right? Subtract everything, parts, add other parts. So minus y plus 1 cosine of dx. And then you could divide everything by dx. Believe it or not, you're allowed to do that right now. Minus y plus 1 cosine x equals 0. It's still not in the form because you have, in the form you have just a y there, right? So you just have a y here. We have y plus 1, so it's not working. I need to distribute, and then I'll kind of have it. So this will be minus y cosine x, and then minus cosine x, when all said and done. And then you just take this part and put it over there, and it's in your form. Okay, so dy dx minus cosine x y equals cosine x. Okay, so now it's in the form, dy over dx plus p of x y equals q of x. Okay. Okay, so I need the integrating factor. Mu equals e to the integral, in this case of negative cosine x dx. Okay. Integral of cosine x is sine x. Integral of negative cosine x is negative sine x. And then on the left, it always devolves. And you got to show your work, guys. You can't just put the answer there. You got to show your work. Okay. Here you can just write mu e to the negative sine x times y. If you don't show your work, me and you are going to have words. There's going to be issues. Okay, so it's either do you want to avoid me or do you want to hang out with me? If you want to hang out with me, don't show any work, and then you're going to be hanging out with me. Okay, I'm not allowed of fun to hang out with anymore. So show your work. Okay, okay. On the other side, you have e to the negative sine x times cosine x. So don't forget, what you're really doing is multiplying everything by e to the negative sine x. So really, you have e to the negative sine x dy over dx minus e to the negative sine x cosine x times y, and this junk turns into this stuff here. Okay. And then on the other side, you're multiplying cosine x by e to the negative sine x. It's just we kind of skip that part, or I do, just for the sake of sanity. Okay. But if you want to write it out, by all means, write it out. Okay. So anyways, here we are. Integrate both sides. On the left, the integral and the derivative kind of cancel each other. You just have e to the negative sine x times y. On the right, you got to do a u sub. Right, so u for negative sine x du will be negative cosine x dx. And then dx will be negative du over cosine x. Okay, so I got integral e to the u cosine x times negative du over cosine x. Cosine x's are gone. You can factor out -1. So e to negative sine x. Y is negative integral e to the u du. And then we can integrate e to the u. That's the easiest integral in the universe. It's just e to the u. Don't forget your integration constant. Then isolate y, so multiply everything on both sides by e to the sine x. And I forgot the back sub as well. So I have the back sub u is negative sine x. Let's just go ahead and put that there. Okay. Whoops. Oh yeah, so it's positive to get rid of the, or you can divide by e to the negative sine x, but it's the same as multiplying by e to the sine x. So you end up with the y equals -1 plus c e to the sine x. Okay, and that would be it. All right, so the test again is on Webassign. You're going to have to write out your answers though on scratch paper and turn those in at the end, just to make sure nobody's cheating their way through math. It's going to really hurt you if you don't know how to integrate and differentiate. You're going to have a bad time in the math program, and in the engineering program you are going to be weeded out eventually. So you have to know how to do this stuff. Please, please, please do not cheat. So that being said, I mean, my test is going to follow the same format. The same type of questions are going to be on there, maybe 1 or 2 extra. But even those will come from my question pool. So I'm not going to give you anything that's not in these question sets. Okay, I don't make up my own questions. I take them directly from there. And okay, so hopefully you'll be good. Just go in there and practice. Practice. Okay, so leave it at that. Good luck, everybody, and we'll see you next time.